I know this is very easy, but understanding how this works will help us understand solving question in several bases. Like let's say for example working in base 5, base 3, base 2, whatever base. This is a base 10 question, though it's not written, we do it every day. If you go back, if you can remember what you usually do, normally this is 4 and this is 2 minus 8. You can't work with this. 8 is bigger or greater than 2, so you borrow from this place. You left with 3, you left with 3 here, and this becomes 12. If you go back a bit and try to understand the mechanism behind borrowing, when you borrow 1 from this, have you ever thought of why it now turns into 12? It comes in front. What actually happens is that this particular question, like we all do in most arithmetic, is a base 10 question, and when you borrow from the digit in front, like let's say you borrow 1 from this, it turns into 10, then you add the 10 to the 2 and it becomes 12. That's the behind the scene, but due to the fact that when we were much younger, and if you had gone this far to explain the mechanism behind working bases, including base 10, we might actually find it very difficult to do our sums. So just tell you to add 1 and this automatically turns into 12. Borrow 1 from the particular number in front, it turns into the base you're borrowing from when it's adding to the number behind. So it's 10 plus 2 and it gives you 12. Then you do 12 minus 8, you get 4. 3 minus 2, you get 1. And that's how we normally work in math. Let's say we have this question in base 5. We have been asked to subtract, and we know normally 4 is greater or bigger than 3, and meaning this can't happen. We borrow 1 from this 2. The 2 will be left with 1. But when the 1 we borrowed is going to this 3, it turns into the value of the base you're working on. That will be 3 plus 5, 8. And now you have 8 minus 4, then you get 4. This is, you left with 1 here, then 1 minus 1, that's 0. Then since there's no number here, you drag it down. So your answer in base 5 is 104 base 5.